So,
That's better. That's good.
okay.
Yeah. All right, Ariel. Happy Friday today.
Cheers.
Cheers. Got my today's drink for me is this Suja juice. Got citrus pineapple, some probiotics and ginger. I'm gonna be healthy today.
Nice. I'm having dessert. So, Sam Smith organic chocolate stout.
Yeah.
Had this a few times, especially around the. My wife used to get this for the holiday, for like Christmas time or something. I used to do, or still usually do a Christmas Advent beer calendar. I started doing a long time ago. So that. I think the first year we did that, she and the kids picked out beers, and that was a Christmas Day beer. It was Sam Smith's.
Yeah. Making
That's,
me jealous in my little sabbatical right now because that's like definitely one of my top favorite picks right there.
rich, chocolatey. Yeah, it is the dessert of beers for sure.
Man, sounds great. Yeah. I mean, I like me some juice though. This stuff is pretty
Sounds
fantastic.
good.
I'm not sick or anything, but it's like vitamin C loaded and ginger, acerola cherry. It's got some probiotics in it. Feel, feeling good. Well, we got some catching up to do because last week
That's right.
we did a new product
New
last week,
release. Yeah.
and I think one of the last videos we left off on was our 13th product, the C5, which just to kind of keep following along that theme of plugging away at our chronology, the gorgeous MXR
MXR is number
would
14
be
in
number
our
14.
product lineup. Yeah. So, and this was a big, yeah, this was a big, it was a big step for us as a company, as a design. The MXR was, um, it was a big deal. There's, boy, if I can even remember all the stories, we'd probably fill a couple episodes. I'm not sure.
Yeah, well, it's
Uh,
it's following on the heels of V1, kind of like the V1 was kind of our reference amp before the R
yeah.
series, and
Yep.
we did another fun episode on the kind of Skunkworks concept amp, the Fulcrum.
Right. Okay.
So that kind of preceded this.
Yep.
And if you guys tune into that episode, you might you'll get the full story, but uh, Charlie built that amp basically on the floor of the machine shop, I
No,
think.
I did.
Oh, but he
I did.
built it.
Yeah.
This guy did.
Yeah.
He built it on the
No.
floor at the
Yeah.
machine shop for the chassis parts manufacturer for us, right just before a CES show,
Yep.
and it didn't work.
No, never really did. Even months later, still had issues. Anyway, so I tried, uh, the kind of the genesis for this product, again, this was one of just Charlie's ideas. And so even before he brought me in on it, it was, he had been thinking on it and had been talking to our metal manufacturer. They've been running through some concepts, and so what it came down to was that Charlie wanted to make this really compact package, super high performance, jewelry like finish, just so sexy that it just could not be resisted. That was more or less the original concept. And so it needed this really compact form factor. And so ultimately, he picked this size first, kind of the chassis design and the size first, and then we had to figure out how to fit everything in it, which um, which was fun some days.
And regarding the size, like there was something to do with trying to make it fit to some golden ratio proportions to a degree.
Well, that's true of every air chassis ever.
Right.
I mean, has always done that. Charlie's really, really big on those that kind of aesthetically pleasing golden ratio. And there's different ways to kind of skin that, because you can using the golden, not just, you know, 1 to 1.6, you can double it, you can do squares of it. There's different ways, because that doing just the golden ratio alone is very limiting. But you can still get pleasing ratios by using multiples or squares of the golden ratio. So when things aren't working out, that's just not, it's not, just doesn't fit, then we have to fudge things. And so Charlie would always go by either factors or squares of the golden ratio.
Well, he knocked it out of the park.
Right.
He did achieve that goal. It is irresistible, jewelry like. It's
Yeah.
very pleasing to the eye.
Yeah, this whole story is there because our original chassis manufacturer, Charlie wasn't happy with what they would be capable of doing, so we actually went out and found a new metal shop to do this, and we started working with them. And they're well known for some other high-end audio manufacturers finishes, and so started working with them, and they developed the whole diamond cut lenticular finish by this big huge fly cutter, the diamond tip fly cutter, and there's a lot of stories there. And so they were able to develop that, perfect that for us, and that can be one of the real hallmark features of this chassis is its finish and the way it catches the light and is almost prismatic in the way it kind of catches the light and disperses it, and it's pretty special. And it kind of feels like the surface of a record, with the grooves cut
Right.
into it.
Right.
And then, but being all one piece, with the heat sinks machined into it, it was, yeah, it was, that alone was a home run.
Well,
So it was
yeah,
up there.
given that the machines or the heat sinks are machined into the chassis and
Or
essentially
the chassis. Yep.
yeah, it essentially makes the entire chassis the heat sink,
Yep.
which is I think another one of the major um reasons why we were able to keep the form factor as
Yeah.
small as it was.
Yeah. Absolutely. Yeah. That's absolutely part of it. And there's a lot of benefits to that. There's, with the design of heat sinks, they are quite a bit less resonant than a traditional extruded heat sink. Um, it's very stiff. It's pretty well damped. It's that one piece monocoque chassis. Um, um, is pretty special that way. And also, if you look at, the inside of these chassis, you see where everything starts as one piece milled out. And so everything has its own little pockets. And it provides um, uh, uh, quite a bit um, um, of high frequency shielding. Um, Everything with its own pocket. So if there were other components or sections, they'd be, pretty well shielded from each other. Um, Also, we came up with ideas for, because there's some wiring that has to be done. So the AC wiring has to get up to the transformers, the speaker wires has to go. And so we came up with these little grooves that we could actually kind of friction fit, press the wires down to these grooves so that they hold really, really nicely, and everything's perfectly laid out and consistent from amp to amp. There's no differences. It's really nicely held, and it works really well.
Yeah. Yeah, I mean, I guess we've been kind of focusing on the outer shell here. The beauty isn't just skin deep though. So we set them up like this so that we could
That's right.
turn it up so people can actually see what we're talking about here. So you've got these are the channels for the AC line, power line coming in, as Ariel was mentioning, and you've got feed to one transformer, and then the other wraps around to the other right there. And same for the speaker wire out. It's machined and guided through the chassis that way, which is just such an elegant solution. I mean, I look inside of a lot of other amplifiers out there, and it's just like my joke is it looks like the spaghetti factory. It's like it looks like there's just wires crisscrossing all over the transformer and just laying all over on top of each other. And with this, you've got the power line in, the speaker wire out, and that's really it.
Everything in its place. It's yeah, we're this is one of the most elegant designs that I've seen and certainly been a part of. And it's probably one of my um probably favorite designs ever. And it took quite a bit of time. So there are so many things to go over in this thing because there's so many, every corner of this thing has its own story.
Yeah.
Um,
Well, this original design, this is the circuit board and what you're looking at here. This is the original MXR.
that's actually, I mean, a pre-production one,
Yeah.
even there. So it was really close to the final production.
Well,
Um,
by it looks like the official launch of the production was July of 2006.
yep,
So you were here about 10 years by that point.
yep.
So yeah, I mean, what do you remember from the early developmental stages of this thing that stand out to you?
Yeah. So I mean, well, yeah. I mean, so once Charlie had placed a stake in the ground regarding the chassis size, the dimensions, and so trying to get everything in. So the first thing is then the next thing is then the transformers. And he also had really lofty goals as far as the power output. And so, this was this was a little bit after we had tried and not succeeded at the big fulcrum amps, which were going to be really high power. And so, with design, he wanted. Uh, so I'm pretty sure the original target was 300 watts in 8 ohms, 600 into four. And so there's monoblocks, of course, and so but doing that kind of power required, a fairly large VA transformer. And so when we're looking at how to fit that in this really short chassis, um, it just wasn't working. It wasn't working. So Charlie worked really closely with Sergio at Mercury Magnetics, and they came up with a couple ideas. And so one of them was to, uh, and it went through a couple iterations, was to make a composite, essentially, transformer out of multiple transformers. And so while there are physically separate transformers, electrically they're acting as one.
Hmm.
And so they more or less split it. So one early version actually had three separate transformers in it. I think there were three in here. Or
Wow.
maybe that was the VXR, but I'm pretty sure it was one of the early MXRs was three. But then we cut it down to two. Now, in theory, you could, with all that space, you could try and make one long transformers. But we learned right about at this point, maybe a little earlier, that doing what we call hot dog transfers, is what we refer to them as. When you start making the lamination stack very much longer than the core width of the laminations, you start running the risk of some pretty loud mechanical noise. Probably just because of that long length of where the wire wraps. It has a long length with somewhat where it's as turns a corner and it has a long span where it has to turn again. So it has a kind of unsupported area that can vibrate and make a lot of noise.
That makes sense.
And so those became just unacceptably loud. So that's why it got split in two. And so Sergio especially did a masterful job in packing as much VA into these two transformers acting as one as we did, and it's has been a fantastic solution. It's worked really, really well. Um, the one follow-up story on that was because originally they were mounting brackets, they were bolted directly to the chassis. And that's where the first couple revisions of the MXR shipped that way. But then even in some cases then, even with this totally sealed chassis, there was still some in certain countries there was some significant mechanical noise still that could be heard in certain situations. And so we looked into that, addressed that, and what we've done in pretty much every product since is that now we float the transformer in basically pour-on foam, so it's no longer rigidly mechanically mounted to chassis.
Hmm.
It's both electrically and mechanically isolated from the chassis, and that cut down noise and any noise transfer to that chassis significantly. Um, so it's another kind of innovation we made that has trickled down to every other product since.
Well, regarding the circuit design on this, this came out before the VX5 amplifier,
Yeah.
right? And so was
So,
this technically the first amp to have a diamond circuit?
well, the original MXR did not have a diamond circuit. No,
Okay.
no,
Okay.
it didn't get the diamond until the 20.
Okay. So
Yeah,
cool. So then
yeah, it
we'll.
was still a long way until we started using the diamond circuit. So this, see, we had done the V5 and V6, um, and we'd done the AX7
Hmm.
at that point. So, so we'd already started, we'd already, switched to bipolar, um, based output stage and driver stages. And so um, this was, an evolution of and a much beefier version of kind of, like the V5 circuit, and with much more sophisticated kind of current sources and kind of input circuitry, trying to get lower noise. And this was first time we started using what we called the the Equilock circuit,
Okay. Yep.
which was um, it's we almost always use our complementary differential JFET input circuitry.
Right.
And so the Equilock, um, what it does is, a lot of the any of the parameters, even parasitic or the normal parameters of the transistor, particularly the JFET in this case, um, those parameters like its capacitance from pin to pin or pins, depends on the voltage across the part. And so if the voltage changes, then like for instance, its capacitance changes.
Hmm.
And so um, and what is a music signal? Well, it's a changing
Always
voltage.
changing. Yeah.
And so the music signal can actually modulate some of the parameters of a active device, and therefore, causing uh, distortion. Now it's still very low level; it's barely measurable, but it's there. So what we came up with the Equilock was run to push the device operating point more into kind of current mode and keep the voltage um, radically more stiff, more fixed across the device, so that even with the input signal changing, uh, the key voltage across the transistor stays almost um, locked at a specific voltage, so that those parameters don't change and radically reduce the distortion.
Hmm.
And so this was, I remember if it was this or I think it was maybe the next product. We'll have a story there where we're taking that even further. Um, the uh, where the just the measured distortion values that we were able to get with a zero feedback discrete design was pretty shocking, and Charlie was super proud of that. And yeah, we'll tell that story later. Um, yeah, so Equilock was a huge deal, getting that distortion down even further than it already was. I mean, it was already fairly respectable um, um, as far as zero feedback designs, and that's and we get there primarily with well-matched devices and with being a truly balanced circuit. Um, 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 uh, um, gets a lot of cancellation and gets that measured distortion down to, a respectable number.
You said
Uh,
Charlie was pretty proud of this. Was this the product that he called up one of his friends to talk about the
no,
specs,
that's
or?
the story I was talking about, and that
Oh,
wasn't this
okay.
one.
Okay.
It was KXR.
All right. We'll
The
save that
KXR
for
was the other one.
we'll save that for the KXR
Yeah,
episode.
yeah. So um, yeah. So yeah, the circuit again is, it was just in the next evolution of kind of the existing circuit. We've been but just again ramped up in parts quality. Um, um, we used the best capacitors we could get at the time. We did a huge search for resistors, and we listening tests to multiple resistors, and to trying to get again, trying to conserve space to try and fit it in this package, we were trying to find a good surface mount resistor, and we did eventually find one. These are Vichet foil resistors, um, and um, and one of the keys was that they had no nickel underplating in their termination, because virtually 99.999% of surface mount resistors out there and most surface mount components um, they have they have a nickel barrier as part of their terminations.
And nickel
And
is
nickel is
ferrous.
magnetic,
Yep.
and so that's our theory, at least, is it that contributes to their imperfect
Hmm.
sound, especially over time.
Hmm.
So we did that huge on it. So we found these. They were more of kind of a flip chip part. So they don't have any wraparound termination, and so it was easy for them to not use nickel in in their um, their construction. So, but they're also very expensive resistors. But for this project, which was not quite price no object, but it was intended to be a real reference top line piece and
Yeah.
almost price no object. Um, and so along with that, even the circuit board material, we want a
That's what I was just gonna
huge hunt.
segue us to.
Yeah, we want a big hunt to find even better circuit board material. And so I yeah, I don't know. I think Charlie spent most nights at home into the wee hours of the morning just researching. Like I never even saw some of it. Like he spent hours and hours at home just scouring web, reading what other people had done, and just hunting, searching
Yeah.
for everything. So anyway, I don't know where we found this, but um one of the U.S. companies, Isola, which they make a lot of circuit board materials for for um um um, um for the U.S. at least. Um, this is called Rogers 4000 series, and so it's more of a ceramic based circuit board material instead of fiberglass,
Hmm.
which most are. And so he was pretty confident that this would be um, better in some ways. And we've talked about this before, where um, what seems to be more. what can be more actually more beneficial are the mechanical properties as opposed to some of the electrical properties. As we find that a lot of the sound imparted in the circuit very much mimics um, the kind of
The,
the
like the physical attributes of the
yeah, the more mechanical and physical attributes of the part, be it the chassis, be it the circuit board material,
or
uh,
myrtle blocks.
motor blocks, yes. Um, but so yeah, so we got some samples, and it was quite a bit harder to get at that during almost 20 years ago now. It was certainly harder to get. It wasn't as common. It does seem to be more commonly used now. Doesn't mean it's gotten any cheaper. Quite the opposite.
Right.
Um, and but so even just making some prototypes um, was a pretty big investment. I think the first prototype was more a functional product prototype. We just used some regular FR4 just to make sure that we circuit was working, such. And so then the second round we started using we used the actual Rogers material, and it was pretty astounding. We're really happy with it. To jump forward a little bit, the our first batch of production boards, and again, so like the batch material like had to be because it wasn't very common yet, almost had to be custom made for us. And they made it wrong, and we got them in, and we're getting ready to send them off to have them stuffed, and we looked at them and felt them, and it was obviously wrong. And again, it's just from the mechanical standpoint. I think I probably have some hidden in the back, just as kind of a novelty.
Yeah.
They were soft and rubbery and sponge spoogey. Like it was. I mean, like the correct material, it's pretty stiff. And you can kind of rap at it. It has a nice hard kind of sound. These were just you could just flex them, and they were like rubber. It
Huh.
was bizarre. And so for fun, we did build up a pair of them on that material and listen to them. And
Just
they were awful.
killed the musicality.
Absolutely killed it. They
Yeah.
just sounded soft and spoogey and just that was again one of those kind of affirming moments where yep, this sounds like the mechanics of the board.
Hmm.
Um, so we had to get the material remade. They did it right that time, so
Nice.
we were able to go into production a little late. There were just a second.
Hmm.
Um, yeah, there were a lot of delays getting this into production. It took us quite a while, for many reasons. Um, and but I'll say that probably for the first time in the company's history, we also didn't feel rushed to. Um, um, and part of that's due to the success of the preceding product, the C5. The C5 was successful enough that we were comfortable enough
Yeah.
with expenses and everything that we had the luxury of time to get this right, to spend the time to make sure everything was right, um, which was a new thing for us. For great. So, yeah, I remember Charlie spending a week or two just like listening to certain resistor values and certain points in the circuit, which like otherwise we would not have had the luxury of doing. But it was just really fine tuning points in the circuit, tweaking resistor values, stuff like that.
It's like the golden
Um,
age of disc playback, and lots of units were selling then, it seems. So
yeah,
lots of those C5s.
yeah,
So
yeah. We saw a lot of them. It was really successful. Yeah, and so we were able to yeah, spent a lot of time on the final circuit, on the final layout of circuit board. One of the last holdups again it was a firmware, which was one of my jobs. I was the only person doing firmware here at that time. And so I'm trying to remember. I mean, the basic functionality was okay, but then again, this was, I believe, the first product where we were trying to add the kind of intercomponent communication. So what became AirLink.
Yeah.
And so we had that was actually, um, we actually were trying to do that in the Fulcrum, that had kind of what were intending to be a similar system. But we actually, actually finalized and developed it here in the MXR. And so getting that worked out, especially in the firmware and everything, definitely took extra time. And then this summer, it took family took a vacation to Germany, partly for the World Cup. And so I was still like not finished with firmware. So I was actually working on the firmware a little bit on that trip. We actually enlisted our good friend Jim White to do part of the firmware, particularly the kind of the bootloader firmware, so that to make the firmware easily upgradable in the field
Hmm.
via the AirLink. And so
Nice.
which is loosely based on RS-232, which is a widely used standard. Many other companies, audio companies, use regular RS-232. Uh, the AirLink differs in the fact that it's optically isolated. It uses, basically RS-232 command structure. Um, and so, but electrically, we wanted to make sure that there's no possibilities of creating any ground loops and ground pollution.
Nice.
So basically, every single AirLink input is optically isolated. Um,
Thank you, Jim.
yeah. Um,
And so
this
the
AirLink.
yeah, so original design had 16 transistors. Is that
Yeah, it had eight per phase. So
fully
16.
balanced?
Yeah, yeah. So it had 16 output devices per unit per channel. And again, this was another one at that point in time. Um, um, on Semiconductor had just come out with, and we'd been actually working with um, on Semi on these parts for even a couple of years prior, with what were called the thermal track output devices. And so it was a fantastic idea, where because one of the problems with a power amplifier output stage is keeping the bias ideally constant, which is very difficult, but at least stable, because as a transistor gets hot, its forward the forward voltage to turn it on, um, as it gets hotter, that voltage drops. So if you have a fixed voltage driving it, or basically generating the bias voltage, that voltage is fixed, but the VBE of the transistor goes down. Uh, the bias of the transistor will go up, which makes it get hotter, which makes the voltage go down, which makes it get hotter, and so it's really easy for that to run away and self-destruct.
Hmm.
And so you always have to have a kind of compensation circuit so that your bias control voltage tracks or even overcompensates for that, so that the bias does not just run away and get hotter and self-destruct. That's a bad thing, right? So the idea with these parts that onsemi developed was that there's a bias diode, and so many bias circuits use a kind of a sensing diode because they mimic the forward voltage of a transistor pretty well, not perfectly, but pretty well. And so they designed a diode into the output transistor package. So then it becomes so then instead of a 3-pin transistor is now a 5-pin transistor because two of those pins are this separate diode that's built into the package. And so having it be sitting practically on that same die, it should be able to track its temperature um, very much better than most other methods. Um, because there you can either have a have a have a transistor or a diode either kind of stacked on top of the output device, or touching the heat sink nearby the output device. There's various ways to try to track that temperature to compensate
Hmm.
for that temperature change. Um, but so having it inside the same package, the device should be like is ideally be, you can't get much better than that.
Right. In
Um,
theory.
in theory, yeah, and it did work pretty well. I'll say that the diode they used didn't match perfectly as far as the tempco of the diode versus the transistor was not perfect. It was, I think, at least overcompensated. So if it once it did go hot, if you use that same voltage, it would at least drop. It would not get out of hand. Um, but so we had to. Um, it wasn't quite good enough for us, and so we used kind of a combination of some of the diodes in thermal track packages, and we had some other diodes separately tracking nearby also, and so we were able to get kind of a slightly better um, tracking of the temperature and the bias. Now, but then as many MXR owners probably know, um, there were some defects in on semi's thermal track design, and so something would happen um, apparently electrically where that bias diode would suddenly change properties and the voltage across it would jump up. And because that's part of our bias circuit, our bias voltage would jump up and therefore the bias would go up and the temperature would go up and they would overheat.
Yeah.
It was particularly frustrating one, because I once I started digging in, trying to track it and figure out what was going on, uh, because it wasn't consistent. It might take a day or 15 days for one of them to do it. And then once one was doing it, if you tried to measure directly across it, just putting some voltmeter probes touching the pins would suddenly fix it, and the problem would go away temporarily.
Huh.
It
Like
was it was maddening trying to track down what was going on.
did the pins have like some capacitance to them or something that they were
I don't know
imparting on it?
exactly.
Hmm.
Don't know.
Yeah.
Never. I was never able to get to the bottom of that. But fortunately, we were not the only company. There were some larger companies using them also. And so them as well as us were able to put some pressure on Semi to say, hey, something's wrong here. We're getting a lot of flack from our customers. We're having to repair a lot of units. And so they did investigate it. They found some issues. They made a revision. Um, and then they sent us a lot of new parts and we started replacing them. I don't remember how long it took, but several months or a couple of years, but we found that even those still had the problem.
Yeah.
So it took a couple rounds before we got reliably good parts.
Well, but yeah, the good news seems that we were able to confirm it was a defect from the parts manufacturer,
Yes.
and so, to which then, we ended up taking care of our customers
Yes.
and making the design right and putting the right transistors in there.
Yeah. 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 We're still doing some of those swaps to this day. But I
Yeah.
think they've pretty much I think we've probably run through just about all of them, and that's not and that's not in factoring the 20 upgrade we'll talk about later.
Yeah.
Um, yeah, so it was a great it was a great idea, and they can work well. Um, and Anyway, that was the thermal track biasing scheme.
Yeah. We've covered a lot on the original MXR. Do you
Yeah,
think we should move on to the 20?
sure,
Because
sure.
this baby is gonna
Oh, hold it down.
have a little more table
All right.
space. Let's set up that beautiful 20 board.
Right.
Look at that.
So the 20, as most know, is we were referring to about 2013, about the 20th anniversary of Ayre. We started working on a kind of a major upgrade to the MXR, and we ended up calling it the 20 upgrade, 20 series. Um, and uh, it was, you know, both for it and the KXR, we were a little bit, unsure of how to make it significantly better enough to make it worth it as, to offer as a big upgrade,
Effectively a new product.
right, for the new product. Um, um, so I don't remember the evolution of all how it works. But this was, um, how did, no, we did we didn't start with the MXR, did we? I think we did the KXR first
For the 20.
for the 20.
Hmm.
Um, I was going to say because, and maybe even did we do the shoot? This is important details I'm forgetting right now because, um, and we probably even did the AX5 VX5 first as well because the MXR, um, we went straight to the double diamond output stage and never the single diamond that we tried in the AX5.
Right.
Um,
And with the double diamond buffer, if you will, that includes an input stage element of that as well, right? There's a diamond at the input and the output stage.
no,
Okay.
no, it's the double diamond, and without giving away too much, it takes the overall diamond structure and more or less kind of splits it in half and then adds diamonds in between. So you can almost
Okay.
call it a triple diamond in a
Yeah.
way. Um, because basically there's two diamond buffers inside of an kind of an uh yeah, inside kind of an overall diamond buffer. So you could call it triple. As far as stages, we call it double. Um, um, Boy, I am blanking on, yeah, because the 20, a lot of that circuitry we really kind of developed and honed in the other products, first in the KXR and then the AX5. And then we really already pretty much fine-tuned it by the time we got to the MXR.
Yeah, because it was in like
Yeah,
8 year difference from the original launch to 2014 when the 20 version had come out. So eight
right,
years in between those other, yeah,
right,
we had
right,
KXR and
right,
other
right,
products.
right. I'm just talking about like the actual working on the 20 upgrade for this, like as far as that diamond, as far as the double diamond um stage, which was kind of the real kind of core of this upgrade. We had already kind of fine-tuned that in just the previous year with the AX5 and the KXR and stuff. Um, uh, yeah, so that was so obviously the big upgrade in the 20 is I mean it's the overall uh double diamond output stage. Um the um the input stage uh architecture stayed a bit the same. We went to some smaller more compact surface mount parts for some of it,
Hmm.
which in general are typically higher performance just because, they're much smaller scale. And so parasitic inductances and lead inductances are quite a bit smaller um, um, with surface mount parts. There's, a lot of people think that there's higher quality through hole parts, but performance wise, and there's a reason why high speed digital stuff is surface mount is because, it's the smaller scale, smaller pins, shorter leads, at least in terms of, fast transitions and lead inductance, they are higher performance.
Right.
Um, so anyway, so some of that input circuitry scaled down a bit, and part of it is to make room for some of the larger diamond buffers we added in there, which is all through hole parts. And it runs pretty hot, and so if you it doesn't show it here, but um, there are some heat sinking blocks that sit on top of these transistor blocks here that then attach to the bottom panel uh, um, to give someplace for some of that heat to dissipate too. Um,
From the diamond
yeah,
circuit
you
itself.
see these little um, pink pads on top. There's a block of 8 transistors here, and that's effectively the little diamond blocks that we refer to. Those are at least the transistor blocks, and so we actually bolt them together so that they track track each other's temperature within that diamond block circuitry really, really well. So they're bolted and pinched together so that
It's so
are
cool.
when they are contacting each other very intimately, uh, tracking each other's temperature.
The transistors are spooning. Um, cool. Yeah. So we got the diamond buffer on here.
However,
Transistors situation did change on this one too, right?
yes, yeah, yeah, yeah. So with the whole kind of double diamond output stage, we moved away from the thermal track devices and so went to the equivalent more traditional 3-pin on semi output devices, which are essentially the same output transistor that's used in the thermal tracks, but just the transistor itself without the um, without the tracking diode. And so then uh, the temperature tracking is then accomplished by the one of the driver transistors sitting right on top of the um, a pair of the output devices. So if you see the first two transistors here are stacked. So the larger output devices are mounted directly to the chassis, and then there's some smaller transistors that are piggybacked on top of them, and then share a mounting screw. So again, they are intimately touching. So that so again, making sure you're using the right transistors so that their temp codes match or are overcompensated overcompensated. And so again, um, this design as in all of our power amps and probably most out there is that as it gets hotter, so that if the musical signal gets larger, you turn the volume up, and it's trying to dissipate more energy and more power and heats up, the bias will actually drop a little bit, so that it doesn't again run away.
So without those extra transistor leads to and the diode to monitor all that, it kind of does a good job of self-regulating
Yeah,
in a sense. So,
yeah. What are the
and
other major changes? So
well, we well
it was a
we took
completely new circuit board. So we just replaced the entire circuit board, obviously. I mean, it's a very, very radical change in the overall circuitry. So
right. Yeah, so you remove
All right.
the old board, put the new one in for the upgrades or
Yep.
um, obviously new products, but there's two less transistors in this design too, right?
Yes, yes. Um, and we remember, and part of that, well, again, I'm
I only highlight that because I just found it intriguing that, we took two away, so 14 instead of 16 and still made the same
no,
amount of
12,
power.
12 instead of 16.
Or 12 instead of
Yeah,
16. Okay,
yeah,
so
yeah. They have to go in pairs per phase.
that's right.
Yeah.
Okay. So yeah, that always stood out to me is that we went with less output devices, but it maintained the
Yeah,
uh,
it's the same power
same
rating.
power.
Yeah,
Yep.
yeah. So it's yeah, that was a necessity more for space. We simply could not fit in um we could not keep that set of transistors. We would have loved to have had um four pairs per side, but it was physically impossible in this again in
Yeah.
this design. Again, retaining the same chassis, not making these chassis changes because this needed again almost all of our upgrades. They need to be backwards compatible. And so we're not going to make a chassis change that would require a chassis upgrade. That just becomes a new product then,
Right.
and not an upgrade. Um,
Capacitance changed too, it looks like. So we have two additional big blue caps that we've added in there. So
well, those are not in parallel. that is that is a different section of the circuit, and
right.
so these that's actually part of um, the input supply regulation. And so
Hmm.
I'm trying to remember, I think we did change the power supply scheme changed radically from the old design because in that 10 years or so we had again learned and im improved a lot. And so um, yeah, so we remember we took that one away. Yeah, so there's so this is the input supply is double regulated. So we have a pre-regulator and then final regulation. And so these kind of wing ones here are for plus and minus first stage regulation. Um, yeah, that's why those caps are there. Um, boy, what else is there? What do we do? I'm forgetting.
And circuit board material stay the same.
Stay the same.
Yep.
Yeah, yeah. There's no reason to change that. Um, yeah. Um, boy, yeah. I mean, it's pretty much just, you know, the complete redesign around the double diamond and the all new power regulation, voltage regulation
Yeah.
schemes. You know, much like many of our products, there's there are a lot of LEDs in there. In this product, they're all on the opposite side of the board. So even if the cover is off and it's powered on, you don't actually see any LEDs in this case. But
Hmm.
I think there's about 128 LEDs used as voltage references
Dang.
on the bottom side of the board.
That's pretty cool. Yeah. I mean, the the simplicity and the elegance of this design just it just takes me aback every time I see it. I mean, you've got essentially four things inside of it: two transformers, a logic board, and then the one main board, which essentially is your audio and power in one.
Yeah, 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 yeah. So one of the let's say like one of the biggest hurdles in releasing this and promoting and marketing it is uh, was convincing people that in this form factor and this power rating that it was not a Class D amp. Not many people believed it.
I get that a lot.
Still,
Still,
yeah,
yeah.
yeah. But yeah, it's 100% true linear power supply, true linear power amplification, and this very diminutive. I had the same problem last time. Diminutive. Still can't say
Got it.
it.
It works.
Package. Um, um, and it's an absolute beast. And you remember the first time I went to review at Stereophile and then um uh, and so John Atkinson as usual did the measurements and and was so impressed by it, kept on pushing it and pushing it and you know uh um and it just kept flying, just kept breezing along, and so it kept pushing and pushing until it finally blew a fuse. It may have blown a regulator transistor just because he pushed it so far. Um, but yeah, it passed with flying colors essentially. It's um, it's a beast in a very small package.
Yeah, I mean the chassis to me reminds me of like I think of like a Porsche 911 or you know even like a Mazda Miata. Like those two cars to me stand out in as like they got the formula right as far as like the overall kind of proportions of the chassis and like they've been in production for 30, 40, 50 years respectively and haven't felt the need to drastically change that design. Like, I guess the Porsches have gotten a little
Yeah,
bit wider, but overall, it's like it's mostly what's under the hood and some other minor chassis kind of mods and tweaks and things that they've done over the years to work on it. But I just don't see much need to change the formula that we have here. It would be like telling Porsche like you need to turn the 911 into more like a Charger or something.
right. Yeah, but yeah, so yeah, again, to go back a little bit, you know, again, choosing that form factor to start with um, was certainly painful in some of the design. I remember, both in this as well as the KXR, um, trying to fight for 50 thousandths of an inch. We were there to get things, crammed on the circuit board or get this pocket open up a little bit so we could fit enough stuff in there and fit the transformers in there and this little pocket for the logic board, like trying to design a logic board small enough and have this pocket that also did not interfere with the transformers. And this was also one that I think the first time we've done this where this combined button and LED indicator.
Yeah.
That was pretty slick, I think. Um, Again, just that super simple front panel. Um, uh, but um, uh, um, uh, but yeah, I mean, it looks really simple now. Um, but it getting it to that point, making everything fit um was a challenge.
And
And we had to get really creative and a lot of long nights.
it's funny.
Just again, fighting for 50 thousandths of an inch here and there.
So funny. And we'll dive into this in another episode down the road, but you would have thought that he would have kind of learned his lesson from this project before moving on to like the AX5 and VX5. But there was with the transformer and that we'll get to that
Yep.
that was kind of a similar story. But
Yep.
how much of a benefit do you think having the shielding integral to the chassis for the transformers and the like shielding the audio circuit from the transformers, like how much of a benefit would you say that that is compared to having some big toroidal transformer right next to the channels that could be spewing
Um,
in.
well, 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 this being, um, this being, um, uh, um, is it, um, um, aluminum, there's virtually no Firstly, no low frequency shielding.
Hmm.
You have to have special um, high permeated steels to be able to effectively shield low frequencies from like a transformer like that. So in this case, almost none.
What about copper? Would copper?
Nope,
No.
not at all.
Hmm.
Copper just it is not effective at shielding
L- Low
low
frequencies.
frequency
Got it.
different things. So in that regards, no, virtually none. Just that the EI cores are quite a bit more controlled than a toroid, which we use in a lot of different directions.
Got
So
it.
um,
Okay.
for that, not much. But again, but also that the transformers are at the opposite end of the amplifier from the input circuitry. So they're a
That's
very
cool.
long way away. This end is all power supply stuff here related in the output stage. And so it is a non-issue
Yeah.
in this design.
Because, yeah, the signal's most delicate at the input
Yeah.
stage there. Okay. And then, yeah, the whole chassis is a heat sink, but in theory, because of the transformers and mechanical resonances that those can produce, it's also a mechanical sink
Yeah.
too.
Yeah. 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 I mean, it is a very dense, and you know, always kind of, refer to it as being well damped just because it is very dense. And, it's, yeah, but it's also, you know, uh, surprising to pick it up because it looks pretty small. You have this kind of sense of, oh, it's gonna be easy to pick up, but also partly because of the relatively short height of the feet, that it's hard to get your fingers underneath. But also that it because it is still like a 30-pound chunk of aluminum, and these iron core transformers, it's surprisingly heavy. It's
Yeah,
very dense.
it's kind of got that Thor's hammer effect, I feel.
Yeah.
Like you see that, like I could pick that up, and then it kind of makes you second guess that.
Right. Right. Yeah, a couple other features that we opted for balanced only, XLR only. Um, but on this, we did offer a external adapter.
Yeah.
But we finally for this product we decided that that was appropriate for this product to be balanced only. Besides the space issues then and just the mechanics of it, there really was no way to put a um, um, uh, a RCA connector in it. And this was also our first product to then we're to go to a 1 mega ohm input impedance.
Oh, that's
That was also a big step.
yeah, good
Um,
catch.
yeah, which again we also feel was a pretty big improvement. I mean, we in previous products we had tried, some of the products that started like 10K, like the V1 started as a 10K input impedance, and we increased it. One of the upgrades went to 100K.
Was the original MXR 1 meg ohm?
Yep.
Yeah. Okay.
Yeah,
Yep.
always. Yeah. Yeah, that was something that Charlie was really adamant about. That he thought that that was, again, it's just and and we and we, and we proved this, in many listening tests. We play around with a lot, but just that 1 meg ohm, really high input impedance, it just extracts every possible detail
Hmm.
um, from the musical signal. It's just it provides zero load to the source, and yeah, it just picks everything up. Again, you have to be careful because that can pick everything else up as well. So you have to be careful with such a high input impedance.
Got it. Does that make it play nicer with other
It's
devices?
yeah,
Yeah.
they won't even know it's there.
Hmm.
Yeah, will be compatible with anything out there, even a particularly high output impedance tube amp or something, have no issue.
One thing that I get a lot of people asking, maybe we can address it here too, is it's an A/B design. So roughly how much Class A do you see on the MXRs before they switch over? That's a common question that I
Mhm.
get.
I I don't have the exact number. It's in the ballpark of 5 to 10 watts,
Yeah.
somewhere in there.
Yeah, you put your hand on it after it's been on for a while, it feels like 5 to 10 watts. Feels like it
Sure.
would be like with how much with how toasty it gets.
Okay.
Yeah,
Yeah.
feels pretty warm, but um yeah, I get a lot of people asking about that. A lot of spec heads
Yeah.
out there, you know. Frequency response is pretty insane on this too.
Yeah, and this again is probably with this era of Sugar Trio, maybe no, I guess maybe the V5 was similar, but yeah, so it's
Like to 250.
yeah, to at least 250, maybe two, yeah, so minus 3 dB, I think at least 250, might be 280 kilohertz. Yeah. Yeah, so it's very, very wide bandwidth. And again, like we did experiments with that. Like we did some things that actually limited that bandwidth. And again, we always preferred the higher bandwidth
Yeah,
designs.
yeah. It's pretty fantastic. I
Um,
mean, it's going on 11 years since the 20
since the 20 upgrade, yeah.
has come out, and we're still selling a good amount of them. This unit here is being built for one of our dealers,
Yep.
David Lewis Audio. And actually, one of the things that he kind of brought to my attention, and I think that this is going to become more and more of a common theme, is a lot of our best customers in this industry, in the hi-fi industry and lifestyle, they're not getting any younger, and there's a becoming more and more of a theme and a trend that people are wanting to downsize rather than downgrade their system,
Mhm.
and this really foots the bill for that for a lot of users because I mean, though it is 52 pounds, it's a lot more manageable of 52 pounds being able to get your actual hands around the thing instead of it being this big, as I like to say, a big microwave sized power amplifier. You know,
Yeah.
it's not nearly as awkward to try to physically maneuver as a lot of other amps out there. But
Right.
and well, yeah, and so 2 years ago was our 30th anniversary, so it'd be cool to get to a point where we can start focusing on this product again and
Indeed.
bring some new advancements out. But we put this new phono stage out. We've got a couple other products in the works for this year. So I think we're going to just be content with the 20 for a while because it just sounds
Yeah.
so good and it is so good. It's hard like how do you improve it beyond this?
There's some ways, maybe.
Another episode.
Yeah.
Well, that yeah, this is definitely one of my favorite pieces that we make. I'm super glad that we were able to get to this and talk about it. Any I mean, we've been rambling for a while. You got any
Yeah.
other cool tidbits that you can think of now or forever hold your peace?
Oh, I'm forgetting a lot. But no, uh, it's no, but just that is probably probably one of the most important pieces in our history as a company.
Yeah.
Like this really, there were some stepping stone, like the original set of products, D1, C5, they all kind of stepped us up. This product in particular took us to a whole new level. And yeah, it's probably
Yeah.
the most important product we've ever made.
Oh yeah. I mean, our first product was a power amp, so
Yep.
this is quite a statement for us. Um, yeah, I think that this is a product worthy of a part two. So, you know, we'll
Yeah.
revisit this down the road, maybe with some updates, maybe not, but we really like the MXR20. We hope you do too. Well, are you gonna finish that beer or what?
Yeah, almost there. Talking too much.
Yeah, I chugged my juice really fast, but yeah, this was a fun episode. Cheers, Ariel. Thank you.
Cheers.
Thanks for all the
Cheers.
campfire air stories. And don't forget to like and subscribe our page. We're almost at 1,000 subscribers, and that
Oh,
helps us a lot. So if you haven't done so, hit that little subscribe button. We'd really appreciate it. And we'll see you next week.
thanks.
Cheers.